One of the questions we're frequently asked is what's different about automotive training authorities, CAN and beyond? Why is it different? Well, let's attack some of the myths that are missed in many of the training classes out there for CAN. First of all, myth number one for CAN is that high-speed CAN is always on pin 6 and 14. Sorry, that's not always true. Here's a 2013 vehicle and high-speed CAN is on 3 and 11. That's the large diagram. Over on the right, we got a stability control program that has no CAN connection, yet it is high-speed CAN. And here is a diagnostic only. The voltages you see on pin 6 and 14 are not the same signals that are on the powertrain transmission control module. It's diagnostic only. Communications training has to be complete. And to be complete, it has to cover the old along with the new communications program. That's missing in many training programs. You say, well, you don't need those old protocols. They've all been replaced by CAN. Not true. Here's a 2013. And it is showing you that on pin 13, we have a K-line, standard old diagnostic connector like we had prior to CAN. On prior to CAN, it would have been on pin 7. Another statement, it's not always universal. And here, the other myth is that the OBD2 codes will help you diagnose these problems and will walk you straight through it. Now, we have a long drawn out sum. We just pulled out a few steps here, 3, 4, 5, and 6, to show you what's going on. We have a lot of things. Go check for the wiring. Go check for shorts. Generic things. What should the voltage be on this signal if it's working? ATA training includes fault pattern analysis of the data bus that shows you how to diagnose communications problems, particularly the tough ones like shorts and open. You will know the voltages in each of the circuits for short and open. We're going to show you diagnostically how to isolate those circuits with fault pattern analysis based on the manufacturing specific diagram. Now, the modules may operate with the same rules, but the data bus configuration varies by manufacturer. Here's a modified daisy chain. One short circuit anywhere in the blue kills the whole data stream, including your scan tool. Your scan tool won't communicate. How do you go about with fault pattern analysis, isolating it on this diagram versus this diagram, which has a linear modified configuration? Would be a totally different diagnostic, and we need a different diagnostic for isolating this short circuit with junction connectors. And sometimes we have multiple junction connectors. How do you effectively use these for diagnosis? What's the signals going to look like when you disconnect them? Because that all changes. Here's a modified junction multi-page with CAN B. What happens when this signal goes to sleep? What should the signal voltages be? These are always alert modules for door locks and so forth. So what happens if they don't go to sleep? Your vehicle runs the battery down overnight. All these things you need to know. Diagnostics that help you in the service bay are missing in many training programs. A technician that recently attended an ATA training class put it best. I learned more about diagnostics in this class than all the other classes I've attended combined. You'll have specific diagnostics that tell you the voltage you will see on hard faults like shorts on high-speed CAN and how to isolate them on manufacturer-specific diagrams.